Hello and welcome to our new video on our new series on API 578, which generally is material verification program for new and existing systems. In the last video, we have talked about what is the intent of this code, what is the scope of this guidelines that are given by API 578. We have also seen that what are some reasons that we are doing material verification, because there is a potential danger that our materials can get substituted. Again, this video is going to be good for the people who are preparing for API ICP examinations, and also the people who are working in asset integrity. They'll have a good idea that what kind of material verification process that they can use depending on their application again. So we'll go to Article 5, Section 5 of this document, which is Material Verification Program. Now, in the last video, in the scope section, we have seen that it is the responsibility of the owner and user to develop a material verification program as per their needs. In that case, this section, the Section 5, is giving some recommendations for the owner and user to install, or it gives us a methodology on how to make a material verification program for any organizations, depending on what are some risks involved, what are some product forms that are involved, what are some areas where verification is needed. All of these things will be written in the material verification program itself. So 5.1 is general. The owner user shall establish a written material verification program indicating the extent and the type of positive material identification to be conducted during the construction of newer assets, retroactively on existing assets, and during maintenance, repair and alteration of the existing assets. For high risk items, the owner user should consider the need for employing a higher extent of in-process and final examination. Sometimes up to 100% is also required, depending on how critical the job is, rather than just a random sampling, which may be appropriate for lower risk items. The owner user should also consider the need to conduct the examination after fabrication is complete at the point of installation to provide the assurance that inadvertent substitutions did not occur. Next is asset components that should or could be included in material verification programs. So these are some items for which a material verification program can be made by the owner or user. So examples of pressure containing component exposed to process condition that are found in equipment and systems that may require material verification program or positive material identification include, but are not limited to, pipe cut lengths, pipe fittings, various kinds of fittings, flanges, forgings, valves, pressure containing valves, instrumentations, weld overlay, lining cladding, bolting, expansion joints, bellow, gaskets, rotating equipment, pressure containing equipments. All of these things you can have a material verification program depending on which things you have on your system. Next is mill test report. Now, what generally happens is whenever we buy a material, the material supplier will generally provide us with a MTC or MTR. So MTC is material test certificate, or material test report will be provided. On this material test reports, you'll have various data that will be given there. There would be laboratory tests that will be mentioned there. That would be some mechanical tests that are done there. So all of these results will be there. Secondly, these can be authenticated copies. That means either the distributor can do it himself, depending on the contract that you have given them, or you both can decide that you require a third party for inspecting the material. So you'll have a third party lab or third party agency that is going to inspect and give it to you. So in that case, it is pretty robust, because at the end of the day, the material that is given to you will have a material test certificate. But the problem lies where you have multiple materials of same kind when you are buying. So let's imagine you have a bar that you need, but you need hundreds of them. In that case, the chemical analysis and the mechanical analysis can be randomly done on some samples. Not everything can be tested by mechanical testing and chemical testing as well, because this will increase cost. Secondly, what you can do is you can do some PMI, positive material identification. You can use X-ray fluorescence method or some spectroscopy methods to identify that what are some constituents of this material. But then again, it has to be very cheap so that it can be done on a large scale. Again, for large scale, why it is required? Because if the object is critical, in that case, most cases the 100% inspection would be needed. In that case, we can do PMI with some methods which are much portable as well. So you can use some X-ray fluorescence technique that are much portable. This means that this code has an intent. So this code tells us that you have to have a material test certificate. There is no doubt about this. But you would also have to do some experiments or do some testing so that you can understand that whatever material you are getting is as per the requirement. When you do this, when you correlate this result with the MTC, this should be same. Okay, if your testing gives you some different results and MTC is giving you some different results, then there is a high chance that material has been substituted. Okay, because understand one thing, the distributor or the supplier will generally have a bias towards selling you the material, okay, at lower costs. So in that case, sometimes substitutions can happen, and these substitutions can lead to a catastrophic failure later on. So mill test report should not be considered as a substitute for PMI because these types of documents have historically not always been accurate. However, mill test reports are an important part of overall material quality assurance program. So not the only thing, we are not going to rely on the mill test report itself, but mill test reports will still give us a good insight about the material. Next is roles and responsibilities. So the roles and responsibilities are based on the material verification program that is developed by the owner. Okay, so this is regarding that. So material verification program may involve participation of several groups within the operating plant or the shop of the contractor, distributor or fabricator when establishing a material verification program. Consideration should be given to the roles and responsibilities that each group has within the specific organizations. These roles and responsibilities should be clearly defined and documented. In the operating plant, this can include those groups responsible for purchasing, engineering, warehousing, receiving, operations, reliability, maintenance, and inspection. Okay, so obviously these groups can also be included in your inspection plan or material verification program. The owner, user, or designee should specify the extent of examination of the new construction and existing assets with consideration of number of items to be examined. So most of the cases 100% inspection would be cost prohibitive. In that case, some sampling analysis can also be done, provided it's a lower risk item. Acceptable methods of examination, location of examination, examination results and acceptance criteria, timing of examination in the work process, process of managing material non-conformances, qualification requirements for personnel performing PMI, methods of documenting and identifying items that are acceptable for the service. Again, new construction material verification program. For the new construction, you'll generally need to have a material verification program because now this is going to act as the reference for whatever things are going to happen on the equipment later on. Okay, so you'll generally have a result which will show you what was the original condition. So this section addresses the fabrication stage, either the shop or the field, prior to the items are being placed into service. The material verification test procedure review, owner, user or designee should review and approve the material verification program and testing procedures to the fabricator, material supplier or the third party agency prior to testing. Timing of verification, the PMI should be performed at the point in time that helps to ensure that proper materials have been used in the fabrication or of an assembly. PMI of components supplied by the distributor. A higher degree of PMI should be conducted on material supplied by the stocking distributors due to potential of unapproved material substitutions as a result of frequent handling by a number of parties. Existing assets material verification program. So existing assets, generally if an organization does not have a material verification program and if a new material is used for the repair, then in that case a new material verification program has to be kept in place. So in that case, this section addresses the assets that are already placed in service where material verification procedure for construction are not documented or not completed in accordance with this recommended practice. It is important to recognize that the previous maintenance activities as well as new construction practices may have influenced the likelihood of unapproved materials substitution. Prioritizing assets for retroactive PMI. So what are some factors that owner user needs to consider so that they can do a retroactive PMI? if a owner user elects to prioritize the equipment or the systems for material verification program or the needs to determine whether the PMI is needed at all, the owner user should consider the following items: likelihood of unapproved material substitution during the previous projects and maintenance activities. So you can think of it as what is the probability of the substitution that is happening. If there is a high degree of probability that a material substitution has happened, then in that case more priority would be given to these kinds of components. So the effectiveness of material verification program when these activities occurred is an important consideration. Considering the consequence of failure due to the improper materials being installed, flammability and potential for spreading fire, toxicity, proximity to other equipment or community, temperature, pressure, mode of failure, and the size of release should be considered. Reasons for a specific material specification: this refers to a criticality of materials of choice. Historical data relating to unapproved material substitution: this may be related to previous experience with material non-conformities in the process unit, operating plant, or within the published information available in the company and industry. Taken together, these factors can be used to determine the risk associated with the possible material non-conformances in an asset. Okay. Now again, here, as you have already seen, that the probability of failure and consequence of failure has came in picture. In that case, the risk-based inspection or API 580 would be taken into consideration to develop that. How do you identify that risk? Okay. Some site-specific factors also needs to be considered. So site-specific factors would be construction and maintenance practices. In assessing the likelihood of material non-conformances, the owner user should also consider material handling, material control, and any PMI procedures followed during the construction of the process unit. Process unit maintenance procedures are also important. Process units in which rigorous procedures for material verification are used would be expected to have a lower likelihood of non-conformances. So basically, how was the construction or maintenance practice when the original construction was done? Reason for alloy specification: in some cases the alloys are used in equipment systems for reason other than the corrosion resistance or structural integrity. In these cases, the mechanical integrity of the system may not be compromised by the material non-conformances. The material verification program may not be necessary in these systems. So based on the experience, you can do it. Okay. Next, these are some examples that will give you identification that what kind of area would be considered as more priority when doing material verification program for retroactive for materials that are already in service. So warm-up bypass lines on pump or check valves, small bore piping, valves, valve assembly, valve bonnets, removable devices such as rupture disc, spacer, blinds, blind flanges, plugs or ring joint gaskets, thermo wells, bolting, piping as a part of packaging system, component without recognized marking, the process systems with history of frequent maintenance requirements, welds, threaded components. So all of these things are to be considered before you do a retroactive PMI. The factors to consider when determining the extent of PMI. So you'll just if you are studying for API ICP examination, just read this once. It is very informative, and most of the things here written are very general in nature. Okay, so just read once. Just 12-13 pages are there. So the factors to consider when determining the extent of PMI for existing assets include historical inspection, material verification program records, number of plant modifications, materials controlled during original construction, equipment modification and maintenance activities, material verification program quality during construction and fabrication, failure mode and consequence and loss of containment, likelihood of corrosion and degradation. So material verification program as an element of maintenance system. So generally, a good material verification program can also be included in a maintenance program whenever you are doing a repair or alteration to your system. That's why this is a huge part of API ICP examinations also. So the principle associated with material verification as a part of installation of the new equipment should also be applied to provide confidence that proper materials are being installed as a part of maintenance activities. Responsibility. It shall be the responsibility of the owner user to evaluate maintenance systems so that material verification program can be designed and implemented to effectively support mechanical integrity needs of the asset. Control of incoming materials and warehousing. The material verification program should be directly applied to the activities associated with receiving materials into a warehouse system. PMI may be performed as a part of receiving function or when appropriate may be performed as a supplier's location as condition of the release of shipment, the material verification program is adopted to provide proper documentation and methods for indicating the materials have been tested and are approved for use. So some maintenance activities are given here. So that's it. This was section 5. This was generally intended for helping the owner and user to develop a material verification program, again for newer equipment as well as the materials that are placed in service already. Another opportunity is provided during maintenance activities, so that will be making sure that whatever materials that we are applying or during the maintenance activity, whatever materials are being used are as per the requirements, and again some material verification program would also be needed there. That's it for this video. In the next video, we'll go to section 6, which will tell us how to do positive material identification and what are some technologies involved there, what are some techniques involved there. That's it for this video. We'll meet in the next video with section 6.